Okay, so the last thing that's going to kind of wrap up what we're doing for this week with solving triangles is law of cosines. So if you want to kind of think of this week, it's split into two parts. This is the end of part 1 of this week. Part 2 tomorrow is a totally different concept. So Wednesday and Thursday are going to be kind of the same thing. Okay? Just like Monday and Tuesday were similar. All right, so those are the 3 types of triangles we've done so far. Law of cosines allows you to solve those 2 types. Okay, and if you're thinking we've already done 2 sides and an angle, we have, but we've never done it where the angle was between the 2 sides. It was always outside the 2 sides. Okay. So that's an example of side angle side. And that's an example of side side side. Now, when you're looking at the table with law of cosines, how can you tell from the table that it's law of sines? Yep.
You won't have any complete rows.
You will have, how do you tell it's law of sines?
You won't have any complete rows.
Not for law of sines.
I thought we were talking about yeah, so you'll have a complete row.
You'll have a complete row. Well, with law of cosines, you wouldn't. You would have the 3 sides, which doesn't give you a complete row, or you could have like a side, and an angle. That's not a complete row either. So the problem with that is, let's say you're missing these 3, and let's say you knew, I did that. Let's, so the checks are going to be the ones you know, and the x's are the ones you don't. So if you tried to use rows 1 and 2, you're going to have 2 variables in the law of sines. If you use rows 2 and 3, you're going to have 2 variables. And if you use rows 1 and 3, you would have 2 variables. Okay? Law of sines doesn't work if you have 2 variables. But law of cosines will. So the law of cosines kind of looks like a formula you already know. That's the beginning of it. What does that look like? Right, looks like Pythagorean theorem, but we know we can only use that on right triangles. So what you have to do is it's almost like an adjustment to the Pythagorean theorem. It's an adjustment for the fact that the angle might not be a 90. Right? And the adjustment is this. And there's 3 versions of this formula. One that starts with b, one that starts with c, one that starts with a squared. They all follow the same pattern. One side squared equals the sum of the other 2 squared minus twice the 2 letters you just used right here times the cosine of the angle that's across from what you started with. Now, let's say that this was a 90. Because you could use law of cosines even if it was a right triangle. You don't need to, but you could. If we take the cosine of 90, think about your graph of cosine. What's the cosine of 90? It's 0. And what's 0 times anything? 0. So if you use this on a triangle that had a 90-degree angle, this whole part becomes 0, and all you're left with is the Pythagorean theorem. Okay. But if your angle isn't 90, then this won't be 0. And then we'll have to subtract whatever it comes out to. So that's the first version of the formula. How about the version that begins with b squared? Anyone think they can tell me what that one would be? Yep.
A squared, b squared.
Yep.
Minus 2ac
Yep.
cosine beta.
Yep. Cosine beta. Again, that's not a different, that's just taking the same formula and writing it a different way. It's very important you understand the pattern, especially for a word problem, because you might not have A, B's, and C's. You just have to memorize the pattern of the formula. And how about if you wanted to write it with a squared? Yep.
It'd be b squared plus c squared minus 2bc cosine alpha.
Yeah. And there's an infinite number of ways you could write this. You could do x squared equals y squared plus c squared minus 2yz cosine of whatever was across from angle x. So don't try to write it down and memorize every version. Try to remember the pattern. Okay? So that's the law of cosines. So notice every formula has every side in it. Every formula has an A in it, a B in it, and a C. Okay? So if you're going to use this law, you can't be missing two sides. It won't work. If you're missing two sides, then you're going to be missing like an A and a B, and that's in all of them. See? So this only works when you're missing up to one side. That's why you can use it for SAS or SSS. You've got to have two sides to use this law. Okay, let's look at some examples. So, you couldn't use law of sines for that because you don't have a full row. So if you were to draw this, this is side angle side. And there's only one thing you can solve for first here. If you look at the three different versions, let's call this like version 1, 2, and 3. What version of the formula do you have to use first? Have to use version 1. Because you're already missing C. So that's something you're missing in every one of them. You can't be missing anything else. So if you use a version that has alpha or beta, then you're going to be stuck because now you're missing that too. So you have to start out with the one that has gamma. Okay? So it's going to be c squared equals, and we'll do a few things as we go, not a lot, but to start out with, but we'll try to do more as we go when we get used to it. So the first thing is, what is a squared? Plus b squared minus 2 times a times b. That's something I probably would have just done in that one step. So 2ab cosine of what? 42. Now, this is the case where the variable is pretty much by itself. You just have to do all this arithmetic on the right. And when you're done, you're going to take a square root. Okay. So what should I do first now on the right? So there's no distributive there that we have to worry about. So this is negative 2 times 4 times 7. So we can just multiply that, but don't distribute it. Unless it's if it was a plus, then you would. Right. So let's just simplify that part. What's negative 2 times 4? Negative 8 times 7. So negative 56 cosine of 42. Now, what would we do next? You could add them. If you're going to follow PEMDAS, you really should do something else first. But adding it technically wouldn't mess this up. Yeah, you should multiply the 56 and the cosine together first. What's very important is you don't do 49 minus 56. You can't do that. Okay? So 56 cosine 42. And that's going to give me, make sure I'm in degrees, 41.616. Was it 41.616? All right, now let's just do all that out. So 16 plus 49 minus 41.616, and we're hoping for a positive number because if it comes out negative, then you can't take the square root of a negative, so you did something wrong. So 23.384. And my last step would be square root. So square root of 23.384. So that's about 4.836. Okay, so let's go back up. And and look at our problem. So, when we, let me write down what we got. 4.836. 4.836. Okay, so when we started, we had A, no alpha. We had B, no beta. We did not have C, but we had gamma. Side, angle, side. Now we know C, 4.836. Besides side, angle, side, which is what it was originally, what other kind of triangle is it now? It is a side-side angle. You can look at it a couple different ways. So it is a side-side angle, and it's one more type. It's also side-side-side. If you continue thinking of it as side, angle, side still, you would use law of cosines again. If you want to think of it as side-side-side, you could use law of cosines again. I don't want to think of it as side-side angle, even though I could. Why is that something I usually want to avoid? Well, not just because it's the law of sines, but something about this particular case. This could give me the two answers, the one answer, or the no answer. When we're doing law of cosines, there is only one answer. So we don't want to have to deal with the two solution thing and all that. So if you start the problem with law of cosines, finish it that way. Don't jump to law of sines. I'm not saying it's wrong. I'm just saying there's something you have to be very careful about if you do that. But if you do it correctly, you can. Right? But I'm not going to. I'm going to do law of cosines, and that will automatically give me the right answer. Okay?
Why is it different for solving it as side angle side or side side side?
Because side angle side and side 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 can only be done with law of cosines. Because you don't have a full row. If you want to think of it as side angle side, that's a little different, but it's going to lead you into something that could be tricky if you're not careful. So we're going to try to avoid tricky. Okay, now you have all the sides. You can find either angle you want, alpha or beta. Which one do you want to try to find?
Alpha.
Alpha. So, to find alpha, we've got to use the third version of the law of cosines. Okay, and we're going to try to do some things out as we go this time. So, I need a squared. So I don't have to keep scrolling up. Can somebody remind me, what was a?
4.
So 16 equals, what was b? 7. So b squared plus c squared, you have right there from the last step. It's 23.384. So we don't have to do that part again. Don't take 4.836 and square it. It's because you already have it. Yep. All right, minus 2 times b times c. So I'm gonna need my calculator for that. 2 times b was 7, right? So 2 times b times c, 4.836. So minus 67.704. That's this whole part right here. Minus 67.704. And what's the last thing that's multiplied by? Cosine alpha. Okay. What would I do next there? Okay, eventually we want to get that cosine by itself, so what could we do first? So this isn't like PEMDAS, this is more like solving an equation now. You have to get the variable by itself. In the last one, the variable was pretty much already by itself, except for the squared. This one, it's the opposite of being by itself. It's like everything is with it. So it's about 2 or 3 steps we have to do on the right side.
So would you have to add those two, then subtract, and then move it to the other side?
So can you give me one step of what you just said?
49 and 23.
Add 49 and 23. So let's do that first. So that's going to give me, let's see, 49 plus 23. Oops. 49 plus 23 is going to give me 72.384 minus 67.704 cosine alpha. Okay. What would I do next? Subtract what from what?
72
Yeah, you can't do 72 minus 67. If you're thinking you can do 72 minus 67, this equation is like this. The 67 is multiplied by something you don't know. So 72 and 67 are not like terms. So the next step is to bring the 72 to the other side. So minus 72. Minus 72. That's gone. And now we need 16 minus 72.384. Minus 72. So negative 56.384. And then the right is still negative 67 times cosine alpha. 67, 704, cosine alpha. Okay, what would be my next step? Yep. Yep, and when I divide, those negatives are going to cancel, so I'm just going to cross those out. And I'm going to do divide. That's gone. And divide. Now, one thing to check here is when you divide, the number in the bottom should be bigger. If it's not, something's already wrong. Okay, because this fraction right here has to be less than 1. Has to be. You'll see why in the next step. I'm not even going to do out what it is, but I can tell 56 divided by 67 is less than 1. So 56,384 divided by 67,704 equals cosine alpha. Okay. Last step. How do we get cosine by itself?
Inverse cosine.
Yep. And you can only take the inverse cosine of a number between negative 1 and 1. That's why if this number was on the top is bigger than what's on the bottom, you've got a fraction that's not between negative 1 and 1. Okay, so that's gone. And let's see what we get. So inverse cosine of 56.384 divided by 67,704 equals, and we get a 33.612. And what did we solve for?
Alpha.
Alpha. Forgot what I said. 33,612. Now we have 2 out of 3 angles. So how could we get beta?
We would subtract this. We would add those two together and then minus the 180.
Yep. So just add 33.612 to 33.612 plus 42 and subtract that from 180. So that gives me 104.380. Let's just check. Biggest side is with the biggest angle. Yep. Smallest with the smallest. That's good. And that's how you do law of cosines. That problem covers both things that can happen in the law. One thing that can happen is you're given the angle and you solve for the side. That's what we did. The other thing that can happen is you're given the side and you solve for the angle. So there's nothing else that can happen in this whole process besides those two things. When we do side, 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 you're going to see that both of those things don't happen. Because with side, 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 you're never going to do this. You're never going to be solving for the sides, ever. Because you have them all.
You can only solve for the angle if you have all 3 sides, right?
You can only solve for an angle if you have all 3 sides, correct. Yep. You need to have all 3 sides before you can find an angle. So in this one, all you're doing is solving for an angle. You're basically doing the last part of what we did, not the first part. The part where we took the square root, you're not going to be doing that here. Now, at a minimum, how many times are you going to have to do law of cosines here? Minimum twice. The nice part about this problem is you're going to find alpha using everything that was given. You're going to find beta using everything that was given. You never have to use one to find the other. So if you use law of cosine 3 times, you would find all 3 of these independent of each other, which means you could get one wrong and not get the other stuff wrong. But if you only do it twice, and let's say you get one right and one wrong, and then you add those up and subtract from 180, then the third one's wrong. But that's how we'll do it. We'll do it twice. So we already did the version where we solved for alpha. Let's do the one where we solve for, let's do beta and gamma. Okay. How does the law of cosine start out to find beta?
A squared.
B squared. Yep.
Equals A squared.
Yep.
Plus C squared.
Okay.
Minus 2 AC.
All right, let's do that out. 2 times A times C. Well, 2 times C is 10, and 10 times 9 is 90. Yep. Cosine of beta. All right, so B squared, A squared, C squared minus 2AC cosine beta. That's good. Okay, what's my first step? Yep. And 81 and 25 gives me 106. Okay. Next step. Subtract the 106 from both sides. So 49 minus 106, negative 57 equals, and what's going to be the next step at the same time?
Dividing by 9.
Yep, so let's do that. So I subtracted the 106 divided by negative 90. Negatives cancel. Bigger numbers in the bottom. Perfect. And my last step. Yep. So we don't want to round anything till the very end. Okay, notice I don't even touch the calculator till I'm for inverse cosine till this last step. So inverse cosine 57 over 90, and that's what beta comes out to. Second, inverse cosine 50.704. Now, is there a case where you could be done the whole problem, a side-side-side problem, with only doing law of cosines one time?
Yeah.
When?
Equilateral.
Okay, if it was equilateral, you wouldn't even have to use law of cosines, because what are all the angles? 60. Yeah. So if it's equilateral, you don't even have to do anything to find the angles. But we're on the right track. What kind of triangle would you just have to do law of cosines? Isosceles. Because if you have two angles the same and then one that's different, you could just find the one that's different, and then you'll have whatever's left over split the difference between the other two. But all three are different, so you got to do it twice. Is there any question how you would do it one more time to get alpha or gamma? Okay. Area of a triangle. So let's take a look at this formula. Start with this one. So the two formulas I'm showing you are based, one of them is based on using law of sines or cosines to derive it. We're not going through the proof of it. This one's actually very easy to prove, but we're not going to prove it. So area of a triangle, the basic formula you have is 1/2 base times height. And that works fine as long as you know the base and you know the height. Well, if you don't, there's a different formula you can use. And there's 3 versions of it, but that's 3 different versions, like the law of cosines is 3 different versions. It's not really. It's a pattern. And if you draw a triangle, call this A, B, and C, alpha, beta, and gamma. Look at each pattern. 1/2, and the 2 sides it uses are B and C. What's the angle where sides B and C meet? Alpha. So it's 1/2, 2 sides, and then the sine of the angle where they meet. Let's look at this one. 1/2 AC. What's where A and C meet? Beta. And then AB, what's the angle where A and B meet? Gamma. So these are all the same, and I just kind of summarized them right here. The area of a triangle can be found by doing half the product of 2 sides times the sine of the angle that's between them. Okay, and that's normally one that I do prove. And it actually doesn't even involve the law of sines to prove it. It involves SOHCAHTOA, right triangle. What you're basically doing in the proof is you're finding the height when you don't know it, using opposite over hypotenuse. You're finding the height. So if you had a triangle like this, that's not the height. The height is like if you were standing right here and you drop something straight down. So that's just another formula for finding the area of a triangle based off of trait. But we're not going to go through the proof of that right now. So let's try an example. Now, this is where it's important that you understand the idea of the formula, because I haven't labeled anything A, B, and C. You have to just use the concept, the 1/2 and all that stuff. So, if I wanted to find the area of that triangle, first thing I would check is, do I know the height? Do I know the height? No. Then I know the base is 12, but I don't know the height. So, based on the formula I just showed you, what do you think you could do for a calculation to find the area? 1/2, 3 times 12, yep. Times the sine of 105. Now, this 1/2, is that part of the basic formula for area of a triangle?
Yeah.
How about the 12?
Yeah.
Yes. This part right here, 3 sine 105, that's your height. If you were to make a right triangle out of this and use right triangle trig, the height of this triangle is 3 times the sine of 105. So that's what you're really doing, finding the height using right triangle trig. So 1/2, the base, and then what's underlined in blue is the height, which you didn't know. But the formula builds in finding it for you automatically. All right. So what's half of 3 times 12?
18.
So we get 18 sine 105. 18 sine 105. Okay, so 17.387. And because it's area, what should I put for a label?
Unit squared.
Yeah. If I knew what the units were, I would have put them, but I don't. And that's a nice little formula for finding the area of a triangle. So 1/2 the product of the 2 sides times the sine of the angle between. Now, I'm going to do this one in a second, but I want to show you something first. If you draw this, why can't you use the formula we just did?
You don't have an angle.
Yeah, you don't have an angle. But what kind of triangle is that? It's side, side, side. So how could you find one of the angles?
Using the law of cosines.
You could do the law of cosines. Would it matter which angle you find?
Yeah. Well, no.
No.
You know all sides.
As long as you know two sides and the angle between it, you could do 1/2 the product and solve for gamma using law of cosines, or beta or alpha. But that would work. But there's a quicker way to do it, and that's to use this formula. Right. This is called Heron's formula. This formula is proved using the law of cosines. That's where the connection to this would tie into what we just learned. The proof of that is a little bit lengthy. So even if we had extra time, that is not normally a proof I go through. The only thing I do is, what's that?
Is that an S or?
That's an S.
Oh.
So, which we have to talk about. So the A, the B, and the C, what are those?
The sides.
Those are the sides of the triangle. Well, S is what we call we'll see if you can figure it out. If you add the A, the B, and the C together in a triangle, what does that give you?
Perimeter.
It's the perimeter. So this is called the semi-perimeter. Semi-perimeter means half.
Okay. Besides this, what other use for that do you ever have?
For the semi-perimeter?
Yeah.
I don't know.
Is it just for this one?
Yeah.
Okay.
Yeah.
You're making a pyramid, you
Making
have
it half.
just flip it.
So, in Heron's formula, A, B, C are your sides, and S stands for semi-perimeter. So this is a nice, quick, simple formula to find area of a triangle where you know all the sides, and you don't want to have to waste time finding an angle. If they asked you to find the angle in the problem, like on the test, I said solve the triangle and then find the area. Well, if you're going to solve it, you're going to know all these angles anyway. So then you could use the formula that we did before. Or you could use Heron's formula. You could do it either way. But if they don't say to solve for the angles, I'm not going to waste time. I'm going to use Heron's formula. So, first thing we should just write down is S. What's the perimeter here? 21. So half of that is how much? 10.5. Now, even if I just gave you this problem, you don't know which side is which. But does it matter? No, because you have to do S minus every side. Doesn't matter which one is which. Okay, so you gotta do them all. So it's the square root of, and what's the first thing?
10.5.
S, and then S minus every side. So let's start here. What's 10.5 minus 9?
1.5.
1.5. 10.5 minus 5? 5.5. And 10.5 minus 7? 3.5. And I just type that in. That's it. So I think it's faster than law of cosines to find an angle and then use the first formula. Okay, but the proof of it is from the law of cosines. That's the connection. Okay, that's why we covered the area of a triangle. So square root of 10.5 times 1.5 is 5.5 times 3.5. So the area is 17.412. And what should I put on that? I don't know. Did I have units in the original problem? No, so I'll just do units squared. Any question on that? I'm gonna skip that one. We usually skip that. And now, for this, I just want to see if we can set up a diagram. And then see if you can figure out if it would be law of sines or law of cosines. So it says a surveyor wants to find the distance between 2 points. And this kind of requires me to explain it a little bit. If I had to explain this, I would have to help you with a diagram on the test. Between 2 points A and B that are on opposite sides of a building. So let's say you've got some kind of obstruction there in front of you. This is point A. This is point B. Okay, and maybe it's not even a building. Maybe it's like a lake, and you just want to know how wide the lake is. So you got a dock on one side of the lake, a dock on the other, and you just want to get the width of the whole lake without actually trying to like run a string or a rope or something like that. So 2 points on opposite sides of, we'll call it a building, whatever you want. Now, to do that, maybe you're standing on land over here at point C. And you can easily measure from point A to C because that lake or obstruction, whatever it is, that's not in your path from A to C. It's in front of you, but it's not off to your side. And it says from A to C, it's how long? 110 feet. Same thing there. Whatever obstruction is in front of you doesn't block you walking from C to B. You can walk over there. And that's a distance of 160. And right, and they would have to give you one more piece of information, which I put in the diagram, but I didn't put in the word column. They would tell you angle ACB is 54 degrees. So if they didn't put it in the word problem, they'd have to put it in the diagram. Okay, so we know that angle is 54 degrees.
Couldn't we just do the Pythagorean theorem to find it?
It depends if you had if the angle you measured was a right triangle. If point A and B were in the exact spot that it worked out that it was 90, you could. But in this problem, to make this 90, you would have to walk forward. Because if you think about if you push point C forward, it would get wider. But maybe you can't walk that far forward because then you'd be in the way. So the question is basically, what is the distance from point A to B? But what kind of triangle is it? It's SAS, which you can solve using Law of Cosines. Yep. And this would be just like solving the first one we did. You would be doing something like this. You'd fill in everything you know, except for the side you're trying to find. And the numbers there are going to get kind of big, because this is when you're going to have to square these sides. So, but that's where you just use your calculator. Okay, and I had the same diagram. So any question on how you would finish that off to solve for the top side? Okay. So we got about a little over 20 minutes, so we'll try to finish up what we can on those two things, and then tomorrow what I'll do is when you come in and I'm checking homework, I'll let you work on whichever one you need to for like 5 or 10 minutes, and then we'll do that again on Thursday. Okay, so that's the homework on page 443. Don't forget, I will be here after school for extra help Thursday. And course selections, we need to start to put those in probably by next academic week. So be thinking about AP stats versus AP.